Hello everyone, it's nice to be here in Poland. I'm called Mäsak, come directly from Sweden where I have been teaching an unusually excruciating course for day job, so I'm really happy to be here and doing stuff I enjoy. Let me start by a little show of hands. How many people here have actually downloaded a Perl 6 implementation and run some Perl 6? Oh, I love seeing so many hands. Cool. The laughter you were hearing from there was around Jonathan Worthington. I suppose he has at some point run some Perl 6 as well, besides creating Perl 6 implementation. So let's begin. My talk today concerns the future and how we shouldn't wait for it to come to us. We should actually build it. So it was 2 years ago. I made this tweet. In my mind, that I have it making it in the middle of the night, but it says here sort of late morning. So at some point, I'm suddenly realizing that I'm going to build an actual physical robot. I don't know when. It doesn't have to be soon, but this is something I really want to do. So robots are a part of our common imagination. We have science fiction about robots. We have all these ideas. Robots will be just like people, but they will made out of metal, or they would look like iPhones or something. And we have all this culture, but where are the robots themselves? How come we don't see them on the street, and how come we don't interact with them and look with them yet? Well, of course, it's really hard. AI is really hard, and all this control theory is really hard. Just making a robot stand up and walk around is apparently extremely difficult. So, for the moment, before I have my sort of interstellar robot laboratory where I can build robots easily, I will just focus on building an IRC utility bot. And don't think of this as diminishing my dreams or anything. I will eventually get to the real physical thing as well. But there's one thing I've been wanting for years, and recent events in my life have made me realize that, hey, I'm working on a limited schedule here. I need to start building these things so I can actually have a use for them now. So I want to build this IRC utility board. What's it supposed to do? Well, it's supposed to be a kind of online secretary for me. I have all these scheduling applications and to-do lists and bug tracking systems, and they offload a lot of mental workload for me. And that's really nice. But I need something to do that for basically my day-to-day stuff, meetings and small reminders and things. In my mind, this is just a project name, but I call this robot Mishu. Not named after Patrick Mishu, as you would think, but it's the Chinese word for secretary. Now it's funny, in almost every language I've come about, the word for secretary contains the word for secret. And just to test this hypothesis, what's the Polish word for secretary? Sekretarz. There you go. So traditionally, the secretary was someone who kept all the sort of secret files for the big boss or something. And they did this even in a special piece of furniture, which often also is called something to do with secrets. So the secretary is the person to do with this furniture. Now, of course, in the digital realm, an IRC, when this is a bot, the secretarial work will be done completely in data structures, and this will be just an IRC bot that I can interact with just as if it were an online personality. So just to give you a sense of what it is I'm building here, I want to have some kind of general reminder function. Can you all read this? So I tell it, remind in 5 minutes, time to have dinner, and then I just go away and do other stuff, and 5 minutes later I get this reminder. So sort of simple enough to imagine. One thing I want you to note here is I'm not trying to solve the general AI problem of language parsing or anything like that. So I've decided to keep it really simple syntactically, and my communication with this bot is basically function calls. So I don't have to spend a lot of time writing special parsers for every imagination conceivable. I want to focus on the behavior of this bot. Now in 10 or 20 years, when people have solved the language parsing problem, I can maybe add this. But for now, what I want from it is behavior. So I don't want to sort of get stuck in an endless yak shaping and things that I don't care much about anymore. And it's also very based on Postel's law, right? So be conservative in what you accept and be, sorry, the other way around. So this is very anti-Postel, that's what I wanted to say. But it really does simplify my life as well, because as soon as you do wishy-washy language parsing, you get all these possible misunderstandings as well. And this cannot be misunderstood. You can put in reminders about people's birthdays. So basically have an add birthday function and just add a person and your birthday happens to be my sister. So they add this birthday and then that day rolls around and I get a reminder about that birthday. Now I'm not implying in any way that I would forget my sister's birthday. That has never happened. But just an example. Here some interesting things show up as well, because as I've been thinking about this, I don't want this robot to disturb me necessarily at midnight, or let's say 3 in the morning while I'm having my beauty sleep. So there has to be some sort of delay as well. It has to pull up these reminders, but then tell them to me when it's convenient. So you're starting to see a kind of workflowy stuff here. Things should be done, but not necessarily right now. We need to push things into the future so that they happen at an opportune moment. And then I find I live more and more online. I have all these, mostly GISTs actually, things that I just put up as online files. GIST is perfect for this, but what the GIST system is missing is an indexing system. I know my file is in there somewhere, but I have to go back manually and look through months and months of different useful GISTs. That's nice in a way. It usually reminds me of what I was doing 3 months ago, but it takes 5 minutes instead of 3 seconds to find the file I wanted. So just link this into the IRC bot as well. And you can start to see how this becomes sort of a personal information tracking system. And I can keep adding use cases like this and make it more and more powerful. Scheduling as well. Right now I do work schedule through Gmail and so on. So just some kind of simple output here showing by default the coming 2 weeks. Busy week here, working in the work week, and then travel in the weekends. And that alone would be really convenient. And then you can sort of extend that to keeping track of by which means am I traveling. Have I booked the train tickets? Have I booked the airline tickets? Is the hotel in order? What's the address of the hotel? And just push everything into the system, kind of like a bug tracker, so that when I need the information, I just go and ask the bot. I could even do some kind of monthly budgeting for this. And say, okay, these were my expenses this month. How did I do compared to my plan? I already have an offline system for doing that, but it's very sort of manual, and I could very well put it into this bot, add it as some kind of workflow as well. So lots of opportunities here. So to build what I wanted, I needed some kind of underlying model. I'm a programming modeling-based kind of guy here. I would like to follow this principle, which you've probably heard of, called KISS. It stands for not really. That's what keep it simple, stupid, or keep it simple, silent. I found this word on Wikipedia. I think it's in the locative, so it probably shouldn't be that. Deposition. Yeah, there you go. What he said.
What he said?
Peace means wurscht. So for a long time I thought I would need events and event sourcing for this. Now, what's an event? Well, it's an object saying something happened, some change occurred. You probably heard about events in GUI programming. There's a mouse click or there's a key press and an event happens. And this would be similar, but here an event would be the next day has happened, or the user added someone's new birthday. So everything that takes place in the system is sort of on the business logic side, not on the GUI side. Event-based programming runs with this idea. It takes events and makes them the primary thing. So there is no longer any program state. There is no longer any register or variable in the program saying this is the current date. It's only one event per midnight saying, oh, here's a new date. A date change happened. And then everything builds off of these events. Things that produce events, things that consume events. And based on the sort of looseness and flexibility of this pod, I thought this was all I needed. And that I could build this whole flexible architecture around events. So anything you have in the system either is an event producer producing events sort of from nothing, or maybe from outside of the system, the user does something which produces an event, or sort of the date changes which produces an event. And then we can have other things in the system consuming these events and sort of looking at two things. Oh, okay, here was an add birthday event, here was a date change event. Together with these two, we should do something new. We should remind the user or whatever. And the reminding of the user will be yet another event. So everything is sort of event-based. But as much as I like this idea, this model, and seeing it work, I couldn't quite get it to work in my mind. And that's a signal that something is missing, right? If I can't really imagine the design of this system, then how can I build it in an efficient way? Particularly, I could easily see how I would run into trouble building these large state machines. As you evolve this program and maybe the scheduling parts or the budgeting parts or whatever, they will get more and more special cases, and every special case will sort of be like a small if statement or a small event handler somewhere. And it will just get very messy really quickly. And you want really a way to manage these state machines. In the best case, you would just want to write them as normal code, nothing special. We have state machines in ordinary programming. We don't talk about them very much because we call them if statements and while loops. And that's how we want to write general code. So events, for all their nice aspects, and I still believe in them in general, they probably weren't for me here in this case. So what I needed was reactive programming. This talk is really about reactive programming. It's not about bots so much as about this idea. It's a really neat idea. So reactive programming. But before we talk about that, we need to talk about process and lazy lists. And this all hangs together in a really nice way, which we'll see. Lazy lists are awesome, and they're in Perl 6, of course. I will show you a really neat short example here. It all starts with the gather statements. How many of you are familiar with the gather statement? Okay, a few of you. Now the takeaway from this is that our program now has two parts. It is the producer part, which generates a lazy list for us. Generally, this one wouldn't have side effects, but here for debugging purposes, we give it side effects. So it says how far it's gotten into the program. And then we have a consumer part, which actually reads out the value. So we have some bit which is producing and some bit which is pulling things out. Now the nice thing here, as you see, the debugging value here, the producer doesn't produce 0 and 1 all at once, as you perhaps would expect as a Perl 5 programmer. If this wasn't a lazy list, the first thing we would see in the output here would be 0, 0, 1, 1. Sorry, 0 and 1 being printed all already, and then just at the end, 0 calls to 1 here. But we have all the things interleaved. It's like this code up here, it doesn't run yet until it's needed. And this code down here, it keeps pulling at the upper code, running parts of it when it's needed. So not until we print the first 0 here does it run the upper part here to say 0 and take 0. And then it stops that. It doesn't go on. So we can print calls here and in general do a lot of other things in due time. And if we never come back and call the rest, well, then it's okay. Then we simply didn't trigger that logic. But we come back here and we print 1 as well. So it's a very nice decoupling here. We've decoupled producer and consumer. We can write these bits of code completely separate from each other, and we don't generally have to mess around with a lot of logic to tie them together either.
Sorry, one question.
Yeah.
If the first line of the consumer would be, say, lazy 1 instead of 0. No. It's the consumer.
Oh, sorry, in the consumer here.
Yes.
Right.
If I write 1 instead of 0, what would be?
Then it would have to run all the way until it found element number 1. Okay. So it would have run all the code. That's correct. It has to run it in order, so to say. Yes?
Another question. This is more complicated. I see this is actually a generator pattern.
Right.
Here, and take is equivalent of Python CL, probably. What if it never makes 1?
Then the gather never runs at all. It just sits there waiting for you to pull things.
Oh, right. Well, but what if it has while 1 takes 0 inside, and I want to say lazy 1?
That's fine.
So
yeah, it stops as soon as it can.
As soon as it can.
Yeah. So you can have infinite loops in your producer, and it will still work.
So it allows both random access and if I say lazy 1 afterwards, will it reiterate?
Yeah, it will always iterate up to the value. So,
but it
you
can
from the start.
No, lists are immutable. So once it's generated a value, it keeps it for you. So if you go back and look at an earlier value, it already has it and it just opens it.
And what happens when we break casualty? So if inside the gather construct, I refer to an element which has not yet been calculated.
Then you might have problems of various kinds. You're talking about pulling in values from the future.
Yes.
Yes. Well, that's more like what we do with reactive programming, as you will see. It's problematic in the lazy contract because it focuses on making the job easy for the producer. So what you're proposing, sort of pulling in more values, it makes the job harder for the producer, and it doesn't like that very much. I think I've done what you proposed, and I think you end up in an infinite loop from that. Okay, so motivating example. I'm glad you started interacting with this bit because I expected that. And the really nice thing is here, we already have lists in Perl 5. And we just take all these list constructs, the way to build lists, and everyone has done map and grep, for example. We just take those and we put the gather construct into them behind the scenes. So all these constructs suddenly turn lazy. You have to excuse me for using Perl 6 syntax for some of these. For example, the double X here is actually a single X in Perl 5. But we sort of tease those apart. So single X in Perl 6 is now for strings and double X is for lists. Because we don't like scalar in this context as much as Perl 5 does. And lines here is actually the diamond operator in Perl 5. So you read a file, and all these, you can just put laziness in them, and it works very, very well. And you know, some of these are for taking existing lists and combining them into new forms. So there are actually two things we want to do here. We want to create new lists from the beginning, like with lines. It's a completely new list coming in from a file. Or we want to take existing lists and transform them in some way to build new structures. And this, to build new structures, is very, very important because that's how we create sort of high-level programs. And here we're doing it with a model. We're doing it with sort of algebra of lazy lists, and that makes it possible for us to write very, very fancy code without introducing new stuff all the time. Now, I would say Steven goes further with this, and it has a couple of more combiners, which you generally will not see in Perl 5 unless you load list utils or things like that, unless you load modules. So we have the cross products here, for example, with which I can say, take all the first names and take all the last names and just produce all the combinations. So it's a Cartesian cross product. If I have 10 first names and 10 last names, I will get 100 combinations of this X product. Now that's very useful, and by default, this one is also lazy. So, of course, by necessity, it will only be lazy on the second list, because you will have to generate these lists as you go. So, while the second list is being generated, you can generate all the combinations, and then you can just go back and use the already generated list. And this, which we will see again later in an example, the zip operator, it takes two lists and it zips them together like this. So it produces a new list with interleaved values. It also works for more than two lists. You can zip several lists together if you want. This is very nice. People like to use this one in for loops, for example. They want to say, okay, I want to loop over these two lists, just zip them together, put each one in a variable. You can have several loop variables in Perl 6, and it just says, okay, now I had $x and $y for each of the lists. Loop over them sort of simultaneously. And it's all lazy. And then we have the general sequence thing here. We saw the special one with 2 dots in, which works like in Perl 5. This general one, we've stolen the flip-flop behavior of Perl 5 and put it in different operators. And this one now generates general sequences for us. So we can do arithmetic sequences, increases by discerning value over time, or geometric sequences where you have the same factor increasing every time, or you just put in the behavior that you wanted to increase with. So all these Fibonacci examples and things, that's with this general sequence operator. And it's all lazy as well. You just use as much as you want on this list, and when you're done with it, then you just stop asking for values. And it can be an infinitely generating list, and we don't get into an infinite loop or anything because of that. I have to tell you, when I toyed around with CPAN, and I think it was 2 years ago or something like that, I had already gotten used to the lazy behavior of Perl 6, and I just told one of the CPAN modules, okay, please generate all the permutations of these 20 elements for me, and press enter, and the computer just sat there. During those seconds and then minutes, I had time to realize that, hey, I've actually gotten used to this lazy list idea very much at a very low level, such that I expect this kind of program nowadays to just start outputting permutations and not build them all up in memory, and then at the end, sort of feed them out to me. Now, and I shouldn't beat down on CPAN modules either, because a lot of CPAN modules actually do this. They give you an iterator and you can iterate through things. So it's possible to do it in the right way, but some CPAN module, which I can't find anymore, did this in the sort of big slow way and then generated everything in memory. So lazy is nice because the producer doesn't block. We have this gather statement that we saw, and we can just put code in there, and every time we have a take, that's an opportunity for the producer to actually take a break. You can read take as take a break if you want. And it just does a little more work each time you call next on the underlying iterator, which you basically never see in Perl 6. So Perl 6 is nice because you still write normal code. You write this gather block, and it works as you think. It works with while loops and if statements like you expect code to work. And it's just easy for the code to pause and give control back to the consumer. Here's a famous problem which was discussed for decades basically, which becomes very, very easy with laziness. The problem is called same fringe. A fringe in this context is all the leaves of the tree here. And we expect to sort of run through the tree in traversal order and find the leaves. So this fringe is ABC here, and this fringe here is also ABC. It's just that the tree looks a little bit different, but they have the same fringe. And the same fringe problem is about efficiently and with a nice program finding this. And there's actually two sub-problems in there. We need some routine to actually iterate through the tree and maybe pick up the leaves as it goes along. And the other part of it is comparing two lists. And we've seen how to compare to lists. We can compare it with this lip operator here. Just pairwise combine the elements, like take the A from here, take the A from there, B and C and C. And we see we can go through them and compare them and say, yeah, they're the same all the way. Now, the same fringe problem can basically, as soon as we have laziness in our language, we just compose these two problems. We say, okay, we iterate on the trees, and then we take the results and just compare them with this pairwise comparison. So it becomes very, very clean, and it's essentially two sub-problems that we are solving here, the iteration problem and the comparison problem. And they are so separated, they don't even talk about each other, they don't even know about each other. They're just combined in the end, that we can reuse these sub-problems as subroutines or whatever in other parts of our program. Yes, question?
Do you do sorting also lazily?
No, sorting is not done lazily. For sorting, you need the whole thing. So that's why I haven't mentioned sort along the map and graph, for example.
Because it wouldn't work without sorting.
Sorry?
It wouldn't work lazily without sorting.
You don't need sorting for this. You just need to iterate through the tree in the right order. And that's all. If the fringe contains different edges, but they would be the same if they were sorted or something, it's not considered to be the same fringe. Which brings us to reactive. This was sort of the introduction to explain how nice lazy is. But laziness also has a lot of limitations. And now we get to reactive, and we'll see those limitations a bit clearer. Reactive programming. Now it's time. A lazy list is a sequence of values that is seen, and the producer can relax and not block so much. Now it turns out, while this is a nice feature for some problems, it's not what we usually actually want in modern applications. We don't care about the producer. An observable is what we want. It's a sequence of values, and the consumer can relax and not block so much. So we've sort of turned this around. Now the consumer is non-blocking. And why is this important? Why is this better for us? Well, because the consumer is usually us. We are writing the program that is consuming something. So we don't want to block. We don't want to make a function call or a method call, and then the program just sits there and nothing happens. We've bound our timeline to this result that's supposed to come back. Instead, we just want to make the method call saying, yeah, whatever, the result will come back eventually. When it does, we'll handle it. So we're talking about synchronous and asynchronous here. The lazy is fundamentally synchronous, and observables are fundamentally asynchronous. So this use case that we were talking about earlier, reminded me in 5 minutes. We're the consumer here. The whole point of this use case is to be the consumer and to offload sort of mentally from the human brain that something is supposed to happen in 5 minutes. It loses its whole purpose if I have to sit around actually logging on this call 5 minutes and then it comes back and says, yeah, 5 minutes are up. Yes, I know, I waited this whole time. Instead we want to go away and then we want to be remembered. So this is quintessentially the thing we want to solve with observables. We want to asynchronously get a callback somehow. So we have an example here. This is from a library I found the other day even. But they make really nice things with observables and they do it in Perl 5. So listening to mouse events to draw a line. Consider this as a use case in some graphical application where you draw shapes and stuff. So you push down your mouse button, you draw the mouse somewhere, and you pull up the mouse button. And during all of this, you want the line to be drawn sort of while you are dragging your mouse button around. Now this can be seen as a pure state machine. There are a number of states here, sort of mouse button down, mouse button up, and we can write complicated logic for sort of jumping between states and so on. But we can also see this from an observable perspective. And just talking about button presses as something that is observable, it is events on a line, values coming in, being sort of push flows on a line. And we can combine these two, button press and button release, with a button stream here. Just merge them together. So merge is an operation that we could conceive on lazy lists as well. But here it makes more sense because we have time as a variable also. So we just merge things in the time order they come in. We also unshift a 0 so that every stream of this kind starts with a mouse button unpicked. And then we have similarly a motion stream. And you see we do all the normal operations here. We do a map, sort of map to the x and y coordinates. That's what we care about here. And then we also unshift the start position of the mouse. So here we have the motion stream. Every time you just nudge the mouse a bit, a new observable value comes in through this observable, and we can react on it. And finally, we build a small dedicator observer just for making this line observation. So first we combine the buttons and the motions into one single thing. We decide to keep 2 button presses, the last 2 ones, so we can see was it a click or a release, and the last 2 motions. And then we filter out the things we care about here. Here it turns out to be just the coordinates. We don't care about the actual button presses here. We filter out when we have the button pushed down, that's what we care about. And then we just grab the coordinates. And finally, so this is something that knows exactly when we are holding down the line and holding down the mouse button and moving the mouse. And finally, we just subscribe to that behavior. We have all the coordinates that we want coming in through the stream, and we can just say, draw a line when this happens, from the starting point to the current point where we're at. So, comparing lazy and reactive, there's actually a really nice connection between the two. What a lazy stream can do, it can return the next value for us, it can die with an error, or it can be finished, it can end the stream of values. That's the only 3 things that can happen along the way. And with reactive programming we have 3 callbacks that we can set on any subscriber which subscribes to an observable. We can talk about what happens when we get the next value, what happens when something goes wrong and there's an error, and we can talk about what happens when there are no more values. So you see there's exactly the 3 situations here, but this is things that go on the producer side, and this is things that go on the consumer side. So this is what gives us the freedom. Suddenly we're writing all the code, all the consumer code on our side of things, and we're never blocking on the value stream. So the big problem with laziness, the word that comes back all the time is blocking. The producer does something heavy, maybe it goes into an infinite loop, or maybe the calculation is just very difficult, and we just sit there waiting for a result. We cannot do anything in the meantime. So we have to have this optimistic concurrency, and sometimes we fail at that. So what's the corresponding big problem with the reactive? What is it that can happen that makes us go, oh, not this again? The big problem with reactive, I'd say, is when we subscribe to something, it says, okay, come back to me when this interesting thing happens. The observer says, okay, I will, and then nothing ever happens. We just go on to infinity. So this is the absolute opposite of blocking. We lose the thing we cared about into the end of time. So what do we do about this? Well, very simple solution, timeout. We just consider time to be another stream that we can mix into things. So we say, if nothing ever happened here, we just combine it with the time stream. 50 minutes later, we come back and say, oh, we timed out on this. Let's do something else. And as I said, the thing we want to reach here is programming in workflows. And the ultimate goal would be to just write a normal code, just write it like we usually do, use if statements, say if 50 minutes later nothing happened, then we can do and go into plan B somehow. And this becomes eminently possible with observables, with reactive programming. think we'll see a lot more about this in the future, because graphical user interfaces need this, web programming needs this, and you can even combine different paradigms like graphical programming and web programming into the sort of same underlying model here, and it all works very well together. We have excellent testability as well. There's an object here which I haven't talked about, which is called the scheduler. The scheduler is the thing that holds the observable and makes it call all its subscribers and so on. And it's also the thing that knows what time it is. And if you control this, you can create your own scheduler. Then you can test things very, very well. You can say in the test, and then 50 minutes pass, and it doesn't need to actually pass because you set the clock in the scheduler. Do we have time for a live demo?
3 minutes.
So let me just go in here to the right.
Actually 1 minute.
1 minute is all I need. So I start this from my program here, and then I go to.
So is it Perl 5 or 6?
This is Perl 5 so far. My intention is definitely to port things to Perl 6, but I need to write a few modules first. So, and this is dependent on me having a good internet connection. There we go. Oh, and the boss got in there first, so she's actually root. Reminder, remember to end the presentation in time. And while I talk about this, do we have any further questions or anything? This was actually the last slide.
I have a question about laziness in Perl 6, because all you were talking was about lazy lists. But this is something more specific than generators, in fact, because you remember the previous values. And
yes.
When you have infinite stream, this is not desirable, in fact.
Right.
So does it work for arrays or for lists?
Yes. When I say that we remember previous values, it's all subject to GC, actually. So if we have nothing holding on to the previous values, we can just drop them and garbage collect them. So
yeah, but this is the matter of optimization in the runtime. So.
Sure, yeah. And they are not streams in that sense. They are lazy lists.
Okay.
It turns out that that's what we needed for... there we go. It turns out that that's what we needed for parsing and so on anyway. It's full of lazy lists inside of the grammar engine.
Bar generators simpler than the lists, in fact, because you just forget the previous value.
Yeah, in a sense they are.
And if you want the previous value, you just add it to some structure.
Right. And if you want streams, you can always implement your own class that does that, and that integrates fairly well with lists as well. So there we go. Thank you.